La 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 la. La 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 la. La 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 la. La 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 la.
Hello everyone, here in this video we would like to talk about what happens to basic parameters like magnetic length, magnetic pole strength and magnetic dipole moment when you cut a bar magnet along both axial and equatorial line, right? Let me explain what the question is once by starting saying what do you mean by a bar magnet. Bar magnet is simply in the shape of a bar where approximately at its tips there is north pole and south pole, each of pole strength m are located. The distance between these two poles is called as magnetic length. Strength of each pole is magnetic pole strength. The product of magnetic length and the pole strength is called magnetic moment, as we have discussed in the other videos. Now you cut the magnet along axial line. So what do you mean by an axial line? This is an axial line passing through poles as well as the center. And simultaneously you cut it along the equatorial line also, line perpendicular to axial line and is passing to the center of the magnet is called as equatorial line. You do both of them simultaneously. In the previous video we have discussed each one separately. Now if you do both of them simultaneously, what happens? That's the point I would like to discuss. So let's take a bar magnet. I'm drawing a little bigger bar magnet just for convenience of visibility. Now you cut it along axial line, say like this. I have made into 3 pieces, 1, 2, 3 by cutting it twice. What happens when you cut it this way, right? So what happens to each of the length? Each piece will have same length of 2L. What happens to pole strength? M dash. This is each pole now. When compared with this is the pole of the first case. So number of the molecules in each piece is got reduced to 1/3. Therefore, pole strength also becomes m3, 1/3. Because molecular pole strength is because of number of tiny molecules. Now the number of the tiny molecules when compared with the total bar magnet, that is this one, is reduced to 1/3. What happens to magnetic moment? Magnetic moment is product of length and pole strength. Pole strength reduced to m/3, length remains the same. So magnetic moment is m/3. So for each piece, magnetic moment is m/3. Say for example, we have not yet stopped there. We want to cut it further, right? So how are we going to cut it is this way. We cut it to 3 more pieces. 1, 2, so it's now reducing, the entire magnet is now being reduced into 9 pieces. This is one of that piece, right? So what happens to this piece after being cut this way? So what's the new length is? This is the total length 2L and this is the part of the length. As you have made it into 3 parts along the equatorial line, that is vertically, each piece will have a length of 2L/3, right? So even if you cut it this way, number of molecules in each piece is not getting affected. So the pole strength remains the same. What happens to new magnetic moment? Length is 2L/3 and pole strength is m/3. So it becomes m/9. It becomes m/9. So if you cut the magnet into 9 identical pieces by making 3 pieces along axial line and 3 pieces along equatorial line, magnetic moment becomes m/9. Let's generalize this. Rather than saying this way, let's generalize this. Let us consider this as a bar magnet. huge bar magnet, each one having a length of, this bar magnet is assuming that have a length of 2L, pole strength M, magnetic moment is the product of both of them. Now you cut that into, say, M pieces along axial line. If cut along axial line by M pieces into M pieces, what happens to the length? Remains the same. Pole strength becomes, say, to eliminate the confusion of that M, because M is already used there, let's assume that it is cut into X pieces, right? So each piece will have a pole strength of M by X. What happens to the new magnetic moment is, length remains same, pole strength becomes M by X, so it became M by X. Now you cut the same magnet in perpendicular to axial, and that's equatorial line. Let it is cut along equatorial line into Y pieces. Then each piece is this. When you cut into Y pieces, each piece, this is the total length L, and this is the small length that you want to calculate. So each piece will have a length of, new length of each piece after cutting along equatorial line is, each piece is having a length of 2L earlier. It remains same even when you cut it along the axial line, but now you made into Y pieces, it becomes 2L by Y. New pole strength remains same. Earlier it became M by X. Pole strength became M by X. It still remain M by X because you have not affected the number of molecules in each piece. New magnetic moment will be 2L by Y and M by X, that is total magnetic moment by XY, where X is number of equal pieces along which it is cut in axial line, along axial line. Y is number of equal pieces that were cut along the equatorial line. So if a magnet is cut along X and Y, along equatorial and axial line with X and Y, new magnetic moment will be original magnetic moment by X is the number of the pieces along axial line, Y is the number of the pieces along the equatorial line. That's how we have to solve these simple problems. Thank you for watching.